Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the Cannizzaro reaction. There are three kinds of Cannizzaro reaction: simple Cannizzaro reaction, crossed Cannizzaro reaction and intramolecular Cannizzaro reaction. And what are the criteria? How the hydride transfer take place, how the molecule undergoes oxidation, reduction. So that type of the thing we have learned or discussed yesterday, and we are now at the end of the chapter, means only last point remaining of the chapter, which is the, let us see, the chapter number 4, which is going to end here with this point. The last point is this one, and the chapter number 4, reaction of unsaturated hydrocarbons and carbonyl bond. The last point is a RUHC reaction. As we know that name itself suggests that RUHC means it is a name of the scientist. He discovered this reaction first time, and therefore name is given to that reaction, that is a RUHC reaction. And what does it mean? What is the speciality? What are the key points to remember as far as a RUHC reaction is concerned? What type of the molecule undergoes or shows RUHC reaction when we are talking about the carbonyl compound. Carbonyl compound are aldehyde and the ketone specially, and therefore both are showing the RUHC reaction. The criteria: the substrate should have a carbonyl compound that, and it will be treated with alpha bromo ester. Remember, the another compound, essential compound required for here to for the RUHC reaction is alpha bromo ester, and the reagent, this reaction carried out in presence of zinc, and followed by hydrolysis. The resulting compound obtained in this reaction is a beta hydroxy ester, is known as RUHC reaction. Understood this one? RUHC reaction means what? When an aldehyde or a ketone is treated with alpha bromo ester in presence of zinc, after acid hydrolysis it gives a beta hydroxy ester, is known as RUHC reaction. Now let us look at as an example. Acetone reacts with alpha bromo ethyl acetate in presence of zinc acid, and on acid hydrolysis gives ethyl 2-hydroxy 2-methyl butanoate. So let us see the example here. A simple example we are going to take here. This is a example acetone, right? Everybody knows that the name of this compound is acetone. It is famous by its common name acetone, and the IUPAC name of this compound is a 2-propanone, and this will be treated with the alpha bromo, or what we can call alpha bromo. Here CH2 at this position bromide, then C double bond O, OET you can call it as. This is known as alpha bromo ethyl acetate. So this is the name of this compound, and this compound further treated with zinc in presence of ether used as a solvent in this case, followed by, this is the first reagent, followed by acid hydrolysis H2O in presence of H plus. The resulting compound is obtained as CS3, then C, here we can write OH, here CS3, this acetone, then CH2, C double bond O, OET. This is known as, this is a carbonyl group, adjacent is alpha, this one is a beta. This is known as a beta hydroxy ester. This compound is known as beta hydroxy. At beta position hydroxyl group is there, and therefore it is known as a beta hydroxy ester we are getting over here. And the name of this compound is ethyl 3-hydroxy 3-methyl-butanone. That is IUPAC name. Don't think 1, 2, 3, 4. 3-ethyl 3-methyl 3-hydroxy benzoate. So that is a IUPAC name. And now let us look at the mechanism over here. The mechanism involve 3 steps here. The mechanism involve 3 steps here. Mechanism involve 3 steps. And let us look at step by step. First step, what is the formation of the zinc salt of enol of the ester. First step, step number first is the formation of zinc salt of enol of ester. This is forming. This is the mechanism involves 3 steps. Step number first, formation of zinc salt of enol ester. So as we know that this one CH2, then we can write Br here, Br, then C double bond O, OET. That will be treated with zinc in presence of ether. What you are going to get? Here you are going to get CH2 double bond CO, Zn, Br, then that remains OET, right? This type of the compound is for enol of ether. This is a enol of ester, right? Enol or ester. This is the first step formation. First step. Now second step. What is the second step? The zinc salt react with carbonyl compound. The zinc salt, this one. The zinc salt, second one. The zinc salt reacts with carbonyl compound. Zinc salt react with the carbonyl compound, and what do you get over here? When this reaction, let us see as a acetone, I am writing this acetone like this, CS3, C double bond O. I am writing for the mechanism point of view, this for sake of mechanism point of view, writing here CS3 and plus this one CH2 double bond, then CO, Zn, Br. Look at this, observe this reaction carefully, OET. And now as we know that this carrying as a negative charge, metal always carries as a positive charge. Here is a negative charge, positive charge. Now what is going to happen? This form as a double bond over there. This is going to attack over there and negative charge on it. So you are going to get here CS3, then CO, Zn, Br. This Zn, Br coming from this oxygen atom to this oxygen atom, and we are going to get here CS3, then this CH2, C double bond O and OET, right? This is a step number second. Now step number third, acid hydrolysis of above product gives beta hydroxy ester. Now let us look at as a step number third over here. Let us see step number third. I am showing here step number third, that is acid hydrolysis. Acid hydrolysis acid hydrolysis of the above product, acid hydrolysis of the above product, here is written is below, but remember acid hydrolysis above product gives beta hydroxy ester. Now this is a structure, here CS3, then COZN Br, this CS3 I am writing as it is, then there will be CS2, C double bond O, OET, and after the acid hydrolysis H2O in presence of H plus, what you are going to get, this bond is a very labile bond, it get hydrolyzed. After hydrolyzing this, you are going to get this one CS3, then this CS3 already there, then OH, now here is a CH2 and C double bond O, OET. This is called as a beta hydroxy ester. Beta hydroxy ester, this is a compound we got over here. So in this way we have seen as a mechanism. Let us look at as another example over here, how this T.Y.B.Sc.CH reaction will be applicable, or let us see how whether you are able to predict the product or not. See over here, let me take one more example so that you can clear your doubts over here if you have any. Let us see here one more example. This is one of the compound I am writing over here. This is the compound, name of this compound is a methyl heptanone. This is called as a methyl heptanone, which is one of the intermediate used in the natural synthesis, and this will be treated with Zn plus this CH2I, then C double bond O, OET, and after the this is a T.Y.B.Sc.CH reaction, T.Y.B.Sc. reaction, and what type of the product you are going to get here? Firstly, you are going to get this type of the product. So here will be this other part remains, this is a carbonyl group and this is going to attack over there. So here OZN iodine, and here will be COOET, right? And after that, after the hydrolysis H2O in presence of H plus, you are going to get the product, this one here OH, and here will be other thing remains as it is, COOET. This is alpha, this one is a beta hydroxy ester. So that type of the product we are getting in this case. So I think with this we have completed as a chapter number 4 over here. And what are the important question as far as exam point of view is concerned? So for example, here state the Markovnikov's rule with suitable example, because carbon-carbon double bond, as we have learned what is Markovnikov's rule. So that type of the 1 mark question may appear here. Propylene, or 2 mark question, propylene reacts with HBr and form 2-bromopropane as a major product, explain. So that type of the question may appear in an exam. Or starting from alkyne, how will you get cis and trans isomer? Or propylene on hydrolysis gives acetone, explain. Or write the intermediate during the addition of potassium permanganate to cis 2-butane. Or it may be write the product of the addition of ozone molecule to propyne, or it may be write the intermediate during the addition of performic acid to carbon-carbon double bond. So write the intermediate during the addition of alkaline, or maybe acetaldehyde cannot undergo Cannizzaro reaction. Just now we have seen, yesterday we have seen. or cyclopropanone with H2O easily forms hydrate, explain. So that type of the question. Write the intermediate during the addition of osmium tetroxide to that 1,2-dimethyl cyclohexene, or write the hydration reaction of acetylene with acetylene molecule. That type of the question may appear, or 5 mark, or what we can call it 2 or 3 mark question may appear like this. Discuss the mechanism of addition of HBr to propylene, explain the peroxide effect. Or what is ozonolysis? Discuss the mechanism of ozonolysis, addition of O3 molecule to 2-butene. Or it may be discuss the mechanism of addition of HBr like this. Or propanone hydrolysis gives 2-propanone, explain. Or explain the formation of cis and trans alkene from alkynes. So that type of the question may appear in the exam. So be ready, or there are predict the product, or write notes like as a Markovnikov's rule, ozonolysis, so Canizzaro's reaction, cross Canizzaro's reaction, Reformsky reaction, halogenation reaction. So in this way we covered all these points as per as a exam point of view is concerned. I think with this let us stop today here. Thank you. Have a nice day.